So thank you so much for everyone for coming. I'll just give a quick introduction to Joshua along with many of his colleagues which are here today. So Joshua and Carrie, along with Florian and Sarah, who were the support team for the EEG experiments, have been working the past years in Dr. Martin Hugerland's quantum physics labs at the university, and now with Dr. Ian Kirk with the support of Dr. Vima Lodia. So in their research, Joshua and Carrie are exploring how the dynamics of brain signals obtained from EEG may provide information about cognitive states. How, for instance, the meaning and knowledge necessary for intentional behavior and decision-making becomes available to the brain via large-scale integration. They are basing their research on the concept of pragmatic information that captures quantitatively describable aspects of self-organizing systems. This presentation will cover the results of a pilot study in order to obtain relevant data and perform preliminary analysis, which will become an integral part of Joshua's PhD research. So without further ado, I will give the floor to Joshua now.
Thank you. Thank you all for coming. And since I've thanked everybody already, I pretty much need to start, I think. All right, so as Leonor was saying, today we're gonna listen to the results of a study in brain dynamics in different cognitive states. We're gonna explore the cycle of creation of knowledge and meaning in meditation and other activities. And it's important to mention that this study was done in 2021 in the neuroimaging lab at Kirk's, at Kirk's lab in Oakland University. And that, well, basically what we're gonna cover today, it's an introduction to Walter Freeman's legacy, the cycle of creation of knowledge and meaning, dynamical brain states in different modalities, data pre-processing and analysis, and some conclusions and future perspectives. All right, so this is Walter Freeman as I met him. He passed on 2016, and I was in close collaboration with him and Robert Cosma, who is the person who introduced me to Walter. And we did a lot of work together on the cycle of creation of knowledge and meaning and brain dynamics movies, the creation of movies to understand brain dynamics spatiotemporally. Walter wrote several books and many papers, but I would like to point out to this particular book, which is foundational to systems neuroscience. It's Mass Action in the Nervous System. It's a book that it's inspired more likely or primarily by Lashley and Carl Pribram, who was his mentor. Then he wrote on brain dynamics, this book called Neurodynamics, an explanation in mesoscopic, an exploration in mesoscopic brain dynamics, and also imaging brain function with EEG. These two books are basically the foundational or the baseline of our methodology for what I'm going to present today. Together with this book, which is the last book that Walter wrote with Robert Cosma, and it's an interesting book. It's about cognitive phase transitions in the cerebral cortex and whereby they enhanced the neural doctrine based only on actions potential. And they use the modeling of neural fields to do that and the behavior between the fields and the action potentials. Of course, Walter also wrote in mind intentionality and behavior, and intentionality was one of his main passions about, how to explain the creation of knowledge and meaning for intentional action. In this book, Societies of Brain, he wrote the neurodynamics, it was a study about love and hate, basically, the neuroscience of love and hate. And also in this book, he put together some of the relationships as he saw them in between brain and mind. These are some pictures with Walter at his home in Berkeley and the lab in Berkeley, where we were exploring movies that we created here in New Zealand. This is a team in Memphis, Tennessee, where Robert Cosma and the people of New Zealand here helped. And this is myself with them. And this is Robert with Walter at the last days of his life. And here's Sarah with me and Walter having a good time at his lab. We, talking about spiritual matters and philosophical issues and brain dynamics. And okay, so with that brief introduction, let me tell you what we're covering today. We're gonna do brain dynamics analysis methodologies, and I'm gonna give you an overview on the two branches of this methodology. One is Hilbert transform-based to study the cycle of creation of knowledge and meaning, and the other one, it's Fourier transform-based, where we're gonna study the dynamical brain states in different modalities. Find some way of classifying them. So for many years, our research questions, particularly mainly mine, of course, Walter and Robert cover these many aspects of my research questions, are how does the brain create knowledge and meaning for value-based decision-making and intentional actions? How do oscillatory systems like the brain, the heart, and the respiration system respond to activities of different kinds like meditation or mathematical analysis, for example? What are the philosophical implications and the repercussions in order to improve the tendency towards a peaceful existence among diverse individuals, cultures, societies, and humanity as a whole? All right, so what was the experiment that we proposed? We proposed an experiment where we could measure how the brain creates knowledge and meaning in different modalities. For example, scrambled words, images which were of the double meaning that you had to wait to actually find. They called, I think, ambiguous images. We put a video also with ambiguous images, but with some music, a song by John Lennon. And then we had some auditory stimuli requesting the participants to actually perform these simple arithmetic operations with some rules until they reach one digit that they had to code, and also a auditory presentation of stimulus where they were listening to positive affirmations like you have peace in your heart and mind, intermingled with gibberish, like things that mean nothing, blah, 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 whatever. And then we also had a meditation modality where people who were meditators could choose their meditation of preference. And if they were not meditators, they could sit down and just relax. There were 20 participants and 6 modalities in total. Okay, so the scalp array that you saw just before on the scalp of the participant, it's basically represented in this network. And this network, which is an EGI hydrocell geodesic sensor net, that's the model, with 128 electrodes, which is important for us because it's quite dense. We actually reconfigure that network here in this matrix, which we actually symmetrically represent left and right part of the brain, prefrontal, frontal, the central area, parietal, and the occipital, and also both temporal areas, in a way that will allow us to actually put some signals here in this matrix, in this array, and whether it was dominant frequency or power, and being able to display them spatio-temporally. This is just a spatial configuration at one time, t, and you can see here the high beta and also theta and alpha. And so we actually created movies and analysis based on that array. We, of course, removed artifacts as much as we could, and that includes the 50 hertz oscillation or 60 hertz, which is just a number that we change in a filter. And then we did a filter for this Hilbert transform part of the methodology, the signals in the band of interest, and apply those Hilbert transforms to actually study the signals to obtain from them signal amplitude, analytic phase, instantaneous frequency, and pragmatic information indexes. This is basically the mathematics of it. I'm not going to go through that, but if you have questions, we can go back there. And basically, you have a signal here that is the original signal. You Hilbert transform it in a band, and then that basically creates another signal, which will become the complex component of a complex number shifted by 90 degrees. And in that circle, when you plot them together, you can calculate the analytic amplitude as the radius and the analytic phase as the angle of that circle in each time. And of course, this radius is dynamic. It's going to be shifting as the amplitude is modulated while the brain is changing and this is done channel by channel. All right, so out of the analytic phase, we actually calculate the instantaneous frequency in a bandwidth, and that is obtained by the derivative of the analytic phase, or basically taking the difference between 2 points and then dividing by 2 pi. And so what kind of experiments did Walter Freeman perform? He worked mainly with rabbits, and he performed experiments on the auditory stimuli, on the olfactory, areas of the brain and sensory inputs, and then also visual. And what we're going to see today here, it's mainly data from his lab at this stage, where we can see what happens when the animal is in background activity before 3 seconds and a visual stimuli is presented. And so brain dynamics is disturbed and amplitude start to change, go up and down. Sometimes the system desynchronizes. This is the phase, the analytic phase. So sometimes the system synchronizes, and that happens in a window of 1 second until the stimuli is resolved. And then the animal goes to background activity, meaning doing what the animal usually does. And instantaneous frequency jumps out of the bandwidth of the bandpass filter indicate that the frequencies have been undetermined, and that basically some moments of desynchronization or signaling, moments that these events are going to happen appear to be represented by these events. Now, these are some of the movies, and here's the front of the brain, here's the left. This is the signal amplitude. This is the aerial view of the signal amplitude, and you can see that there are some rotation patterns and also pulsating patterns. So there are some vortices and some pulsation patterns, which for us signal the fields that carry knowledge and meaning around the different areas of the brain until the stimuli is resolved and the animal can make an action. In this case, this is a human being. Now we're, in participant 0 of this pilot study, where this human being is processing a word, which is scrambled, this fourth stimuli, and we have filtered the signals of the participant in low gamma. So you're seeing what's going on. And this is the amplitude, analytic amplitude square and log 10. This allows us to see when the amplitude goes up and when we observe these null spikes, as we call them, and how they relate to the instantaneous frequency jumps, signaling important processing events in the brain, where we conjecture meaning and knowledge is being created or assembled in order for the animal to do, or the human to know what to do with that stimuli, fight and flight, or just enjoy the day. This is another movie where we see the theta band and the low gamma band, and in the literature, theta and alpha and low gamma and high gamma have been mentioned to be theta or alpha, a gating band, signaling the beginning of something relevant to the processing of a stimuli and the end of something relevant to the processing of the stimuli. And gamma is being shown to be more of the processing band, how the band integrates the information. And so here you see significant raise of the analytic amplitude, and then you see how gamma starts to create all sorts of situations between the back and the front of the brain and the sides and so on. And so these movies, of course, have to lead somewhere quantitatively. And in a paper that Freeman and Vitiello wrote, Nonlinear Brain Dynamics as Macroscopic Manifestation of Underlying Many-Body Field Dynamics, they talked about the Pragmatic Information Index, which is a ratio that they call the ratio of the rate of free energy dissipation to the rate of change in the order parameter. Analytic amplitude being the order parameter is a vector of, in the case of the animal, 64 signals. In our case, it's 144 of the 128. And then this vector is somehow resolved in average and then divided by the Euclidean distance between all the different amplitudes at one point in time to signal or to give us a measurement of how close these signals are or far away from each other. And so this Pragmatic Information Index was named like that after the work of Atmanspacher and Scheingraber. And And so basically, we're going to see what this index can give us as information. So when I showed you before the signals that we gathered from the Hilbert transform, now we use those signals to create this pragmatic information index. We see that in the pre-stimula windows, this index is pretty much, you know, in the lower range of values. But as soon as the stimula hits, after a period of intense attentiveness to the stimula, which may be, you know, in a time of 100 milliseconds, an incredible raise of that index happens. I mean, significantly different. This is the average of many repetitions of the experiment. So chaotic exploration is how we name that. It's the search space of the animal to try to classify that stimula. When there is, again, a very big synchronization moment, or in between the desynchronization moments and the synchronization moments, we understand to be that the animal classified for wrong or for good the stimula, and then after that, the animal have to integrate what to do with that stimula, fight and flight or enjoy, etc. Then after that, the animal will go to background activity. In humans, that's different because we don't resolve the stimula so simply. We may actually create meanings, intermediate meanings in the period of 3, 4, 5, and 30 seconds sometimes, where these amplitudes go up and down. And I want you to focus here on this moment where the analytic amplitudes actually raise in all channels, most of them. And here the instantaneous frequencies are all within bandpass, which means there is an intense synchronization between the signals. And so I've put that here in this window so that you can understand that the Euclidean distance between all the signals that conform the analytic phases of each channel tend to 0, while the analytic amplitude, the average analytic amplitude here, has grown. And so when we do create this calculation based on analytic amplitude square and the Euclidean distance, we have these peaks of information, which we called intense processing times. And this is where we conjecture most of the creation of knowledge and meaning. It's happening in the exploration phase. And when we are in background activity, we're more in quiet times, which is what we think the animal, it's taking the time to integrate the stimulus that have already explored in terms of what it means and what to do with it. And the same for humans. So at the end of this period, the human being should press a button. And this is another way of studying these signals, but it's smoothed out in taking the average in a window of time instead of displaying it second or millisecond by millisecond. And these are the same signals, but in different areas of the brain, which leads us to these kind of plots where we can see when and where these pragmatic information indexes show significant values. Like, for example, here in the prefrontal cortex and the frontal cortex, and a little bit on the temporal occipital cortex. And at these times, too, there is some kind of relevant activity. And so the analytic amplitude square is shown here. All right, so what statistics and parameters we can derive from all these? We can compute the number of peaks per second, per person, per stimula, per modality. We can calculate the mean time between peaks, which we call the quiet processing. We can calculate the mean time of the peak, which we call intensive processing, and the percentages overall over the whole period of the stimula resolution of quiet processing times and intensive processing times. And here are some of the results that indicate here the quiet processing times in green and the peak times, and then we add them all of them to calculate the percentage of the whole stimula, and same for the quiet times. We have here peaks per second in different bands, so we can look at that too and look at every modality, what happened with every modality in every band, and then do some analysis to see if there are some bands which are significantly different than others and some modalities which are significantly different than others. And of course, we can compute the probability distributions of each modality in terms, let's say, for example, the time of peaks or the mean peak times, and then look at that and see how significantly different these modalities are from one another. And we see that meditation, actually, if we put here the cursor in 60% of the time, or 0.6 probability, we see that these are the times, less than 100 and something milliseconds. While if we try to understand the same for the words modality, we see that the times are greater. So these modalities seem to be more intensive processing than this one. And of course, when we do that for the whole data for all participants, instead of averaging participant by participant, we see the same relationship, more or less, where sentences, positive affirmations is closer to meditation, and words is farther apart from meditation, and everything is in between. Now, what is this telling us? This is telling us that the theta band, for example, and the low gamma band, in terms of resolving the times of processing, show different significant results. These error bars are pretty small. And also the same in quiet processing times. For the different bands, these quiet processing times or intensive processing times are different. This scale is pretty different than this one. So that's telling you that there are much more quiet times than there are processing times. And we saw that for one of the graphs, but that seems to happen in general. Okay, so if we see all the bands and all modalities, okay, so we see a linkage here between alpha and high gamma, as I was pointing before, for all modalities. And this linkage, it's still here. It also exists for theta and low gamma. But the real difference between all these modalities is how low beta, high beta, and low gamma have dropped significantly from the rest of the modalities. And generally speaking, we can see here too that these two modalities have less intensive processing peaks per second in this case than maybe these two modalities, or particularly this modality. So we're starting to see differences between modalities, and the main difference is when people are in meditative states. So let's go to the movies again. I wish I could give you some real popcorns, but at least I, put this bowl here. And I like to see brain movies a lot, because brain movies actually allow me to learn as a person who is testing wines would learn, to recognize wines, different tastes, different flavors. So here is participant 1 and participant 9. And I would like to invite you to see if you can see differences between the two participants. Of course, this is really hard in one go, and I don't expect anybody to be able to do that. But you can see that there are some differences, pulsating differences here, and maybe here are more tornado patterns. I don't know. Whatever you can see, that would be great. And then look at this next movie here, which is the same presentation, the same stimuli for the same participant in the same band, but in a different index, analytic amplitude. So in this one here, you can tell, in this one here, you can tell, let me see, you can tell that analytic amplitude is stronger here, more intense than in here. And the center of the brain seems to be more on the lower values, while here it's the periphery of the brain, left, front, back, right, and that is more intense when there are raising. So there are some differences here that you can, like here, this one, that you can start to see, yeah? Now, as a first summary, we observe a significant difference between meditation and other modalities. We observe the linkage between alpha and high gamma, and between theta and low gamma. And now we're ready to go to the next part of the methodology to produce via Fourier transforms, dominant frequency band indexes, Shannon entropy index, Pearson's skewness coefficient, and signal power. And those indexes, we think, will allow us to classify better the modalities and the participants in terms of meditators and non-meditators. So this is an imaginary frequency spectrum. This frequency is power. So if you normalize that, you can get sort of a probability distribution, and then you can add the power of a certain band, let's say alpha, which is between 8 and 12 hertz for us, and then calculate that for every single band as we've defined them, and then calculate which band is dominant or shows the dominant frequency. You can also calculate from the spectrum the entropy index, Shannon entropy index, and the Pearson's skewness coefficient, which is based on these three parameters: the mode of the distribution, the mean, and the standard deviation. A really good way to explore the dominant frequency is to calculate these spectrograms, where we have here the different frequency bands, 10, 20, 30, 40 hertz, and then look at the different areas of the brain represented by one electrode of each area. This is prefrontal left and right center, frontal same left, center right, and then you have the central area of the brain and the temporal areas, and then you have the back, parietal and also occipital. You can see that the dominant frequency of these areas of the brain, it's mainly alpha. But if you move to the occipital, there is also strong power in alpha, but also there is more power and diversity of bands being significantly important in the power spectrum. And these windows are moving, but each 10 seconds. So we see the dynamics, the preliminary dynamics of these dominant frequencies in different moments for different participants. And again, we watch a lot of those movies. So if you want to have a better understanding of what's going on there, then you have to collapse all these information into how long, how many milliseconds each participant in each modality spend in each band. This one in meditation tells you that this participant here spent a lot of time in alpha, very little in theta, and some time in beta and high beta, and almost nothing in gamma, apart from some areas, but this is not the same scale, so don't be deceived by these peaks. Here you can see the whole brain, and the whole brain, it's mainly signaling that this participant was most of the time in alpha, with some, other bands kind of active in terms of dominant frequency. Now, when the same participant is watching videos, the story changes. Alpha sort of drops, and in the prefrontal cortex, theta goes up, as well as in the low beta in the occipital parts of the brain. And you can see the different, configurations of times that they spend in each band at the level of the whole brain. So these two modalities are very different, watching videos or meditating, for that participant at least, at the very least. All right, so we can also normalize that kind of information that I presented before into a graph where we can calculate the percentage of time per area of the brain that each participant spends, and the stimuli, the total of the processing of the stimuli. So here, if we sandwiched all these bands in one graph, you can very definitely see how much more theta, alpha, and beta there is than there is gamma and low gamma, high gamma and low gamma. And these are other graphs that we can analyze, but this one is the one that illustrates dynamically the displays of the dominant frequency each 500 milliseconds, half a second, for meditator and a non-meditator in the modality of meditation and non-meditation. And here you can see that for the meditator, he or she spends most of the time in alpha, and some areas of the brain do transition to other different bands or dominant frequency bands. While watching videos, it's much more diverse. And for the non-meditator, alpha, it's also more present in the meditative or relaxation state, but not as much as in the meditator. And the non-meditator show way more diversity in terms of frequency band transitions from band to band, from in every area of the brain. Okay, so let me give you a brief window to the relevance of first-person perspective analysis here. And this is very brief. This participant here volunteered her subjective analysis. She's part of the team of that helped to put this together. And the only thing that I want to point out to a very thorough analysis she did that I'm not presenting is that she pointed out to the similarities that she saw in these two modalities in terms of the data. And she was telling us that, okay, so we could think that actually brain dynamics is very similar in these two modalities, listening to positive affirmations and meditating. But actually, she tells me that, you know, she never listened to the meaning of the words. She just was enjoying the quality of the voice and actually being in a meditative state. So we could think that these two activities after this report are actually meditation, are not listening to sentences. But the story turns back to be different when we go to the theta band, and we see that in sentences, actually there is a strong prefrontal cortex in theta rays. And that's very different from meditation. So even though it appears to that person that this is a meditative state, still there are some aspects of the auditory processing and the classification between gibberish and non-gibberish that person may be actually doing when it's listening to sentence before she or he presses a button. All right, so let's summarize here. Meditators in general present strong alpha and less variability. Non-meditators present more variability. Some of them present strong alpha, which signals that they're pretty relaxed people overall. And that's also in the meditative modality. And so relaxation can be as good as meditation in terms of some participants, you know, and I don't mean good or bad in terms of, you know, good or bad qualitatively for the person, but good or bad in terms of representing the differences between modalities. So that creates some kind of diversity too. So in order to sort out these distinctions, we need more indexes. So we computed the Shannon entropy index, the Pearson skewness coefficient, as I was telling you before, based on the frequency spectrum. And then these are the formulas for the Shannon entropy index and the Pearson's coefficients. I'm not going to go there now unless you want to see them later. And then let's come to here. Based on those indices, we created these landscapes. And of course, we can create movies of that too, but this is enough to show you an average of every single millisecond of these indices, showing us that this index for the meditator shows way less diversity or entropy than for the non-meditator. And the same happens with the PSK coefficient, the Pearson's skewness coefficient, for both for the meditator and the non-meditator. This one, it's less diverse, less variable, and then the meditator in meditation. The same applies to video. However, in this area of analysis, we see that for this modality, both participants have more variability, and the variability can be detected also in different areas of the brain, not just between modalities. Yeah, different areas of the brain has different variability. And so this allows us to actually classify not only modalities, but also between different types of participants in terms of meditators and non-meditators, and within the different areas of the brain that we have explored. So when we do the same analysis for mean total power derived from the power spectrum, we can collapse similarly all the spectrums computed in windows of half a second, and for one participant in every modality, and then see what the power spectrum is doing, and the total power, which is just the integral or the sum of all these points. And then we take that and collapse it into this graph. This should be points, but I put it in line so that you can see the tendencies between modalities, which is kind of a generalized tendency. And then we put them here with their respective error bars, and meditation shows up to be significantly more powerful than, for example, video and imaging processing. And words and sentences are close to each other together with the arithmetic operations. And okay, so on. So what happens then when we compare meditators to non-meditators in power? Then we see a difference in this, particularly in these two modalities, and no much difference in the rest of modalities. These are the less demanding processing modalities, as we saw before in the analysis of pragmatic information. And these ones seem to be equally intensive for all participants, and power decreases. So that's an interesting feature. Then here, when we see the entropy index, we see how power actually increases from meditation to other modalities significantly. All right, and we had to normalize this data to actually compare really well these participants. And when we do that, we see that there is a difference between the meditators and the non-meditators, and in both of these modalities, and again, in those modalities, they don't present significant differences between them. And the same happens with the Pearson coefficient, which I'm not going to stop too much. And now we have the dominant frequency. We use the standard deviation because, of course, the mean of the dominant frequency will be so central that we wouldn't be a good classifier. But the standard deviation is, and it shows us how the modalities are really well classified, not as much because of variability, the non-meditators between the meditators. However, it's a good classifier for the modalities. And so when we make a summary of all this information, we can actually collapse this information into a two-dimensional graph where we put total power and the entropy index on the other axis, and same for the PSK, and see that there is an inverse linear relationship when we put the modalities between power and variability. So these modalities, which has more power, has way less variability than the modalities who have more power, which has way more variability. And so this is really interesting because this allows us to classify between meditators and non-meditators as well as between modalities, as you can see here. And of course, in the non-meditators, things seem to be a little bit more towards one area of the plane. And that tells us that perhaps there is a certain influence in being a meditator through the types of activities you perform in the day, meaning meditation may have an impact in the way you perform activities. However, or if you're relaxed, not necessarily meditation, but this definitely, it's just a preliminary view, so we need to deepen that a lot. So the same happens with the Pearson skewness coefficient, and you can see that this is similar to that. When we do that for the standard deviation and the dominant frequency, we see something similar, but the relationship is, it's not inverse, it's linear in a positive way in terms of how they behave, but they still, are very well differentiated by these two indicators in the plane, as well as the non-meditators, which are more clustered, this time towards the right. All right, so when we actually take power out of the picture and put entropy index with PSK, then we see that these two indexes also create a very good plot of differentiation between modalities and also types of participant in terms of meditators and non-meditators. And again, the cluster is here. So for most indexes, this works well to classify both modalities and participants. And when we put the standard deviation in total power, then we see an inverse relationship. The bands that have more power have less standard deviation in the dominant frequency, and the bands which have more standard deviation has less power. And also, again, meditation is quite apart from the rest of the modalities for the meditators as opposed for the non-meditators. So that leaves us with some summary observations where we have to, I take it to be that there is some difference or a difference between meditators and non-meditators in terms of the behavior we see. We observe significant difference between modalities. These differences are also reflected in total power by itself and when contrasted with H and PSK. And we also put another dimension to the study, which was measuring with heart rate variability monitor, a sensor on the ear, what the heart rate variability was doing. And this basically, through the coherence ratio, allows us to determine if the person is stressed or relaxed. And there is literature on that. I'm not going to go there today unless you have questions later. But via this coherence ratio, we also saw that for all participants, meditation and relaxation shows a higher coherence ratio, though with a huge variability, and that only can be better by more participants, a sample size which is bigger. Here we cannot really classify the two because the errors are too big, but still there is a tendency of the non-meditators to be what in this literature or body of literature, it's called coherent or psychophysiological coherent. And the other activity seems to be more stressful than particularly relaxing or meditation. That shouldn't be a surprise. Okay, so in conclusion, what are we seeing here today? I focused basically on brain dynamics and the creation of knowledge and meaning. I mentioned very briefly the heart rate variability aspect of this all. I didn't mention respiration, but in meditation, in almost all schools of meditation, respiration is a very important aspect of meditating and relaxing, and particularly rhythmic meditation. And the body of science that relates these three in terms of meditation and relaxation, it's called psychophysiological coherence. So this is a body of science that we followed very carefully in the past. And then we used mainly an analysis of the classical physics presented in brain signals, electrical signals, but Vitiello and Freeman talked about the quantum field theories in condensed matter. They talked about Nambu-Goldstone condensates as the fundamental reality that supports the macroscopic behavior of the classical fields. We see that there are interesting books on that area. If you want to read them, I can guide you through that. We also aim at understanding way deeper the transpersonal psychology of Maslow in terms of peak experiences, plateau experiences, and being values, the Jungian psychology of synchronicities, the Piaget psychology of learning, accommodation, and assimilation. And also all of that was actually the foundation or these branches of science that we're trying to explore had their foundation in this thesis I wrote in 2009. I published in Otago University called The Brain of Melchizedek, a cognitive neuroscience approach to spirituality. And with that, I just want to finish by saying that in 2016, one of the people I have collaborated with, Paul Werbos, we published this paper in Frontiers, Regular Cycles of Forward and Backward Signal Propagation in Prefrontal Cortex and in Consciousness. And here we did a study review and we analyzed spike sorted and burst sorted data of the prefrontal cortex from the Buzaki lab, which we think is one of the best labs at the moment in systems neuroscience. And this is consistent what we did with regular clock cycles of about 153 milliseconds, which is about 6.5 hertz, which we think are hardwired by evolution to be the baseline of the rhythms of an animal or a human, rhythms like respiration or heart rate or even learning rhythms. But Freeman gave us something else. Freeman gave us the neuroscience, the systems neuroscience based on field dynamics associated to the dendritic activity of neural population in different areas and modalities, which feedback with the action potentials. And in doing so, he and Cosma enhanced the neuron doctrine, where different emergent synchronization and desynchronization patterns of rhythm emerge to suit the level of intelligence required for intentional action and decision-making, both animals and humans, holistically engaged with the environment in diverse feedback loops. All these neurodynamics foundation serves as a baseline for learning and intelligence. And we conjecture that will lead us in the direction of a more robust field of research, still controversial, that pertains to synchronization between humans, which incorporates developmental cycles of learning, of accommodation and assimilation a la Piaget, eventually allowing for peak experiences a la Maslow and synchronicities a la Jung, and perhaps all that mediated by respiration techniques, meditation, and psychophysiological coherent states that enable a finer attunement to the rhythms of life, both ecologically and culturally. And this we intend to do with the support of the body of research that Bressler, Kelso, Tognoli, and collaborators at the Center for Complex Systems and Brain Science in Florida Atlantic University have done, which Kirk Ian knows really well because he spent some time in that lab. And okay, so basically we would like to further explore EEG activity to improve our understanding of the hard problem of consciousness and human value-based decision-making. We would like to also further explore the cycle of creation of knowledge and meaning as reflected in pragmatic information that will ideally lead us to a better grasp of biophysics and the neuroenergetics of the brain and the different categories of meanings, like semantic meanings and sacred meanings, for example. We would like to develop the semiotic understanding of the brain-heart respiration dynamics, and basically as manifested in psychophysiological and behavioral signs and symptoms, and be able to tell the state of a person by those psychophysiological signs and symptoms in terms of how the person is stressed or not stressed or so on. And we intend to further brain-heart respiration synchronization studies to understand better peaceful inner states and their relevance in intentional action and decision-making, and also synchronizations between people, and provide in the future a cognitive neuroscience framework to study meanings and values that will integrate first-person perspective, subjective experience with third-person perspective. And with that, I just want to slow down this rhythm to make it in 40 minutes and take a deep breath to acknowledge actually from my heart and express my sense of deep gratitude to Walter Freeman, to Robert Cosma, to Grant Gillette, Paul Werbos, Giuseppe Vitiello, Florian Schubler, and Songjul Chi, most of them my collaborators, apart from Giuseppe, with whom I have never written anything together, but I have kept a very close dialogue, and I visited him in the University of Salerno in 2019. I just want to also extend my deep gratitude to Martin, to Ian, and to Peter for their support to make this PhD project possible. From my heart, thank you so much. Emanuel Tognoli and Stephen Bresler at the Center for Complex Systems and Brain Science. I just want to thank them too for the good times and that they gave us and the explanation in their labs of the things that they're doing there. And of course, without a doubt, to Vima, who was absolutely a great support, not just when she was in the lab, but also when she couldn't be in the lab. And so for that, we're very, very grateful to Lenore for all, the organizing job together with Meg and other fellow researchers and students at the Neuro Lab, Sam, Kathy, Nitish, and Steven. Thank you so much for the good times you gave us there. And of course, to Florian, Sarah, Carrie, Karen, Kali, Colin, and the rest of the team at the Embassy of Peace in Firianga, thank you so much. And without a doubt, to all the participants whose names must remain undisclosed, I just want to say that from my heart, Kanui Temihi, thank you so much, all of you. Thank you very much. And now we can go to the question and answers part, if there are some questions and answers.
Before we go into questions and answers, just wanted to give you a thank you, Joshua, for your presentation. That was very informative and very interesting. Thank you so much for that. And yeah, if anyone wants to ask any questions, feel free.
I have a question, Joshua. It's probably, I don't know if it's appropriate, but I'm only your secondary supervisor, so I feel I can ask a question without it seeming too set up or anything like that. I have a few actually, but the most pressing one for me is with the plotting of the entropy index and the meditators versus the non-meditators. You have a compelling argument, I think, that there's a better differentiation with meditators and in the meditation phase versus the other tasks. What does that mean? How do you interpret that? What are meditators doing better at something?
No, I don't think it's better or worse. I really don't think it's better or worse. And you, of course, are going to get an interpretation from the point of view of a meditator. So, of course, we need an interpretation from the point of view of a non-meditator, or many of them. But from my understanding, of what meditation has done for me and others that I keep close contact with and converse, I think that we've learned at will how to self-regulate and how to, bring the stress hormones down to a very, very low level. And in doing so, we've noticed through the years that our cognitive abilities and our way to interact with others have changed for good. Meaning, we can listen better, we can absorb information which is foreign to us in a way that is not conflicting with other people's points of view. We can actually address tasks like we never felt we would, like Carrie being an artist doing quantum mechanics. I mean, that's absolutely, you have to ask her dad what he thinks about that, if she would allow that. But what I want to say is that meditation, in our experience, has an impact not only in our physiology, but in our cognitive abilities, in our health in general. Now, that's something that for years in different labs in the world has been studied, and there is compelling evidence building up in different labs. So I think here we have the opportunity to do our contribution and explain what we've learned. Now, that's from my point of view. In sports, for example, or when I play jazz, that's a necessity. You cannot go into the ocean a big day without being in a certain relative calm state. And you have to sit down in those swells relaxed. So that means you have to override the limbic system when you see a fight flight kind of wave that you don't know if you're going to make it, and just approach the situation in a relaxed mode, and then being able to surf it and victoriously go to the shore and say, wow, that was a great wave, even though it was pretty big. And so you need to be calm. And I think Hawaiians have that in their culture. They called the Americans when they came howlies, okay? Ha means breath in Hawaiian, and haole means without breath, because they didn't know how to breathe. Those guys, I imagine, learn how to breathe in nature and the ocean and all sorts of things. And so I'm not saying that other cultures do not know how to breathe. I'm just saying that some people in some places, in some times, have learned the power of being relaxed in the aloha spirit, in the aroha spirit, and and address life from there until survival needs kick in, and then we lose it. And so the meditation and breathing techniques help you to regain back that center where you can approach reality in a more relaxed way, a more efficient way. That's my take on that, Ian. I don't know if that answers your question, but that's my take on that.
Okay, as a non-meditator, I can actually, that was a longer answer than I was expecting, but yeah, but I'll consider that.
All right.
Calmly.
Well, otherwise, buy a hammock and walk in nature. I mean, you don't have to meditate. There are many ways of relaxing. See, Sam is there relaxing right now. He's not.
He calls it meditating.
Yeah, why not, with good music and whatever? I mean, there are many ways of doing the same thing.
Yeah, thank you, Joshua. Good answer. A great talk too. I forgot to mention that.
Thank you,
Joshua. Can I ask a quick question?
Please do.
Really, really interesting talk, and of course, the words that jumped out at me were Piaget and self-regulation, and just wondering about the sort of the age limit you would consider in an experiment such as yours. Like, I guess it's a two-part question, but what's the age limit of effective meditation for children, and secondly, do you think that could be part of your sample in future?
Great question, Karen. Well, first of all, let me tell you, we're all learning of that, okay? So I don't have a definite answer to that, but what I can tell you is that Emery Brown has shown how different age has an impact in power in the brain. So we can see developmental measurements on spectrograms dynamically, under anesthesia or non-anesthesia, and the effects of that in different age ranges, yeah? Now, we see that the brain of the children show much more power, okay, than the brain of the elders, yeah? And I think that, of course, they are in the process of absorbing way more information before they spend that energy, and entropy starts to kick along, along the time of the arrow of time. There is a moment that brains are absorbing more than processing and driving conclusions to actions. Yeah, apart from the involuntary actions of crying for milk and things like that. So I don't know exactly when is the time for a kid to meditate, but I would say that kids start to meditate as long as they're in the womb and the mother is meditating, because the neurogenesis of the baby, it's colored. We know that it's colored by the brain dynamics of the mother. So she is more or less a biological gatekeeper to inner peace in the future. Okay, and I can see that, and in many cultures that is already, like in the Jewish culture, you're part of the peaceful community. I mean, let's say in ancient times, if your mother is Jewish, she determines, the quality of that. And I'm not saying that cultures that are motherly driven are better than the ones that are fatherly driven. I think that's not the case. I think that the mother biologically, if she's in peace and no alcohol is there, then no alcohol syndrome or no, very stressful things are going to be in the kid more likely. The propensity will be like that. But of course, when the babies are out, then the environment, external environment, will determine somehow what's going to happen to that person. So if the environment is violent or stressful, then that baby that was nurtured in the womb to have more propensities of peace may lose it. But also, if the mother was not too peaceful, but the environment is more peaceful, let's say grandparents or caretakers, then that little baby may heal and become peaceful too. So there is no clear cut on that. But when children should start meditating, I don't have an answer for that, because I think children are very, very well when they're in the paddocks playing and exploring nature and the world, and meditation maybe should come a little bit later, at the age of 12 or 13, or maybe to some a little bit before, when they can actually understand how they get stress in community interactions, and how that kind of breathing rhythms and technique help them to mediate their stress and their anger to interact with others in a more harmonious way. So maybe I would say 12, 13, which is the age of bar mitzvah in Hebrew, and first communion, or many cultures' initiations. I think at the moment when we're going from children to adulthood, I think that's a good time to start with breathing techniques and things like that.
That sounds good. And I think Piaget would agree with you with the sort of concrete operations about that time as well. And I was thinking when you were saying about the womb, a lot of my research is about early life influences of later outcomes, and our biggest problem that indicator or risk indicator has been maternal stress during pregnancy. So yeah, interesting that the converse would be true to promote good outcomes.
Yeah, well, I wrote a chapter on my master's thesis in the Brain of Melchizedek on brain values, spiritual values, and pregnancy. And I'm very happy to share that document with you. Actually, you can download it from the Otago archives.
I will. Thank you.
You're very welcome.
Just a question in the chat, Joshua. Eric is asking, how did you classify meditators and non-meditators?
We ask questions to the meditators, yeah? To the participants. Do you meditate? Yeah. And some people answer yes, some people answer no, some people answer a little bit, some people answer yes for many years, etc. So we took anyone in the same group, the ones that have been meditating for a year or the ones that have been meditating for 20 years as meditators, even though that it's a really diverse group. So that's not necessarily exactly the same. And then we put on the category of non-meditators, the people who answer, no, I don't meditate. Yeah, but that doesn't mean they don't meditate. They just don't know that maybe they reach meditative states when they relax, when they listen to music, or they even solve mathematical equations, which takes you sometimes to meditative states. I know that because I love mathematics, so I can gauge my rate variability when I'm doing equations or when I'm meditating, and sometimes it's the same. So in that sense, we just went on this first pilot study based on the response, the answer of the people to the question, do you meditate or do you not meditate? Yes, some people told us, well, I pray instead of meditating. So we said, is that relaxing for you? And they said, yeah. So I said, well, we consider that as a form of meditation, which is prayer-based instead of empty-based, or, trying to do mindfulness or something like that, which many people report. I mean, in that work that I mentioned before, I've put all the different ways of meditation and prayer and achieving those states of inner peace or mystical experiences or whatever, the states could be classified as more peaceful by first-person perspective reports or anecdotal evidence.
Thank you for that.
Oh, thank you. Eric. Thank you, Eric. That's a really good question. I wish that we may be able to actually expand on a bigger pool of people where we can have more meditators of different schools and be able to tell the difference, as well as non-meditators, and of course be a little bit more selective on the range of ages and things like that. Try to think better how to select the group, and in order to have a bigger sample with a more universal scope towards a larger population of people. I think that's important to do. I don't think we can draw fantastic conclusions on a sample of 20 people, but we can see that it's heading towards a really interesting outcome.
Can I ask? I know it's getting late on a Friday now, and some of us have to go and make ourselves more calm in one way or another. But can I ask about the future? You mentioned several times about interpersonal behaviours and activities, and how the brain might, I suppose, synchronize, to put it simply, I suppose. How do you propose to go forward and look at that sort of thing, or do you propose to go forward and look at that sort of thing?
You mean synchronization between people?
Yes. Yeah.
Yeah, that's a really interesting field of research which I would like to advance. I don't know if that will be part of the thesis, but I wouldn't mind working on that in parallel, because I kind of never stop on what I'm doing, and I love it. So the people at Atlantic FIAU, basically Kelso and Tognoli and even Bressler and others, have already done brain synchronization between people in different activities, okay? So that could be playing a game or meditating or all sorts of different types of activities that signal that there is going to be a form of synchronization between people, okay? And so my take on that is that there may be, people who actually may synchronize with others just by thinking about them, but because they have such a strong connection that they could do that. And I saw a video of people working with electromagnetic fields and capacitance of the body to actually modulate music, a woman that it's absolutely brilliant to watch. And this she does very sensitively with her hands, approaching two antennas and creating music like that. And so for me, when I think about an order in the universe, I don't think that we're limited just to a solipsistic understanding of ourselves in terms of neurochemistry only, and the brain producing all the aspects of consciousness that can be. I think that consciousness can be more of a collective body of interactions that are not limited to the brain of each person, a little bit like Jung proposed it, or maybe even Rupert Sheldrake or Teilhard de Chardin in the noosphere. But these are areas have been so, put aside to priorities in science, which I think it's appropriate for the past. But in the future, there's no reason why we shouldn't explore that more deeply. And so I wonder if we find people who are really synchronized in life, like jazz musicians or people who talk about the vibe, yeah, and or the peak experience or the the flow or whatever they describe to be an order that they experience with others, which, by the way, Carl Jung documented really well in Synchronicities, and Carrie has just written a database of synchronicities, which I think Carl Jung would be very proud of her, even though she didn't study Jungian psychology or anything like that. I mean, we can use all this information to understand how in the world we can test these synchronizations between people, and if they occur in the brain. Because it could be that there are such synchronizations that do not occur in the brain, that are occurring at the level of the mind, or what Taylor Desjardins called noosphere, or Rupert Sheldrake calls morphic resonant fields. And that's, of course, a field that in the science as we know it is controversial, but nevertheless, there is good cases on that should be researched. So I think the place to start, it's in the Atlantic University, in the Florida Atlantic University Research Center, to understand synchronization in activities where there is conversation, virtual talk, and things like that, and then move on to a more non-verbal communication synchronization type of activity. So do it gradually from what can be synchronized, in terms of swimming or playing, a game in computer or anything like that, or talking even. Synchronizations between mother and child, which we have studied already. People, not we, Carrie and I, but people in the world have studied. And see if there is synchronizations, visual synchronizations that actually synchronize the brain too. So there are many different places where we can start, but I think the mathematics and the first baby steps are to be found in Florida Atlantic University.
And as you know, yeah, a place that's dear to my heart. Yes.
Yeah.
Thank you, Joshua.
You're very welcome.
Actually, Lenore, if there are no more questions, I'm going to actually mention this is a cognitive neuroscience seminar, of course, and many of you know this, but some perhaps don't. That we lost Mike Corbelis, who died earlier this week, well, Joshua clearly hadn't heard that, and I think I won't go on too much about that. Where there's been some quite a lot of talk around that, but he was very well. Basically, cognitive neuroscience in psychology would not exist, at least in its current healthy state, if it wasn't for Mike. And certainly, he was instrumental in setting up the EEG lab that we've been using. And I'd just like to say that just appreciate his contribution to us in Auckland, and in fact the world of cognitive neuroscience. He was certainly New Zealand's best known cognitive neuroscientist, in fact one of the best known in the world, in fact. I can say this, Joshua, he would have enjoyed your talk.
Wow.
So thank you very much.
It completely surprises me, and I just wanted to tell you that I was hoping to see Michael here, to tell him how much I've enjoyed his literature, and also how much I enjoyed a video where he talked about meditation and mindfulness not being necessarily, better or worse than actually a wandering mind. And I agree with that fully, because you can be in a very peaceful state with a wandering mind, and we see that in people. And so I wanted to share with him that for me, meditation was not just being empty, but being able to find peace, whether you're dreaming about the future, thinking about your loved ones. And now I am thinking about him with a lot of fondness. And I wish I could have said to him, thank you for your work. I really do wish I could have said that. And I wish that he will, wherever he's now, he can receive my genuine appreciation for him.
Thank you, Joshua.
Yeah.